Welcome to the first of 3 videos showing the different 2D orbits projects that I'll be releasing on GitHub very soon. These are currently running on Godot 3.4, but can be ported to Godot 4 easily. This first project uses a custom class called a KPlanet that applies Kepler's formulas and other fancy maths to solve and visualize basic orbits on rails in 2D. The main game scene consists of several sliders that display and control simulation timescale speed, as well as several parameters for the orbit like eccentricity and the different anomaly values. Several of these sliders will automatically update as the simulation plays out, but others can be used to modify the parameters in real time. The scene also contains a log panel where we'll print out the solved parameters of the orbit. There's a bunch of useful information in this readout, but one particular callout is the node 2D position and rotation of the orbit. Because of the way Godot handles rotating nodes and drawing arcs, we had to repurpose the argument of periapsis orbital element so that it represents the pivot rotation of the orbit around the central star. That orbital value serves no other purpose in our 2D simulation, so it made sense to use this for rotation. And here, we can change the eccentricity of the orbit. This causes the anomaly parameters to align when the orbit is a perfect circle. So let's look at some of the GD script code. The simple game script handles the main game loop with simulation speed, interacting with the sliders, zooming in and out, and logging the orbital readouts. The heavy lifting in the project is done with the KPlanet scene and script. This class handles the math required to calculate and convert the orbital elements like eccentricity and the anomaly parameters. It also handles drawing the expected path of the orbit using ellipses. The class contains several functions that can be used to solve orbits in different ways, depending on the input parameters. For example, the KPlanet can solve Kepler orbits using the solve from true function, or it can use the solve from state vectors function, and there are other functions as well like solve from eccentricity anomaly and solve from mean anomaly, and solve with time, that can be used in different ways depending on the needs. And we want to visualize the orbit, not just see the numbers, so the KPlanet also handles drawing the orbit ellipse, as well as several important points around the orbit like the apoapsis and the periapsis. And that's the tour for the first project, using the KPlanet class to solve and display 2D orbits on Rails. Like I mentioned, we'll publish the entire project on GitHub soon. Our goal is to reach 250 subscribers before we do that, but that doesn't mean that we might not give early access to the private repos before then. Drop a comment and let me know if you're interested. Thanks for watching.